Hey everyone, and welcome to the deep dive. This entire deep dive actually came about thanks to a suggestion from our friend Curt Robbins.
Oh, yeah.
Yeah, senior technical writer. And he pointed us to a really interesting blog post.
Really? What's it called?
It's called, Can LLMs Write Better Code If You Keep Asking Them to Write Better Code?
Okay. So, I mean,
An intriguing title, right?
yeah, very intriguing.
And it was published on January 2nd of this year, so 2025, by Max Woolf.
Oh, Max Woolf. Okay.
Yeah. And it kind of makes you wonder, can we truly unlock some hidden potential in these LLMs by just repeatedly telling them, hey, write better code, write better code?
Yeah, it's kind of like giving it a cheat code or a secret code to level up its skills or something.
Exactly. So in the blog post, Wolf starts off, and he's pretty upfront about this. He's like, I was pretty skeptical about this whole LLM code copilot craze that's been going on.
Okay.
He wasn't really seeing these massive productivity gains that everyone was talking about.
Yeah, I mean, whenever any new technology comes out, especially in our space, there's always so much hype. Like, is it really going to live up to its promises?
Exactly. And so uh, Wolf was using Claude 3.5 Sonnet, and he was blown away by its ability to follow prompts, especially when it came to coding. He goes on and he's like, the prompt adherence is incredible.
Oh, wow.
Yeah. And that's coming from a data scientist like Max Woolf. That's a pretty big statement.
That is a pretty strong endorsement.
Yeah. So we've got our skeptical data scientist, we've got our cutting edge LLM, and now we need a challenge. We need a coding challenge worthy of their combined intellect.
Exactly.
So what do they do?
Well, Wolf decided to challenge Claude with a problem that was simple to understand, but offered quite a bit of room for optimization. He challenged Claude to, from a list of 1 million random integers, find the difference between the smallest and largest numbers, whose digits all add up to 30.
Okay, so not exactly your average leak code challenge here.
No, definitely not your run-of-the-mill coding challenge problem, which I think was a very smart move on his part, because he wanted to make sure that Claude had never encountered this specific problem during its training.
Okay, makes sense.
Yeah, he wanted to really see how it would approach a brand new, a truly novel problem.
Got it. So what was the first attempt like?
The first approach he took was what he calls just casual prompting. He fed Claude the problem description and basically just let it generate the code.
Okay.
And the initial result it was pretty impressive. The code that Claude generated was accurate, it was functional, but maybe not the most efficient solution.
Okay.
It had an average runtime of 657 milliseconds.
Okay, not bad, not bad. But sounds like, there's some room for improvement there.
There is absolutely room for improvement, especially a particular function called digit sum. It seemed like that was the bottleneck in the code.
Gotcha.
So this is where things start to get really interesting. Wolf, in his next prompt, simply added the phrase, write better code, and the results were remarkable.
Really, just write better code. That's it.
That's all he added.
Wow, okay, tell me more.
Okay, so Claude went ahead and completely refactored the code. It created a new class, pre-computed digit sums to speed up the process, and ultimately the runtime dropped to 240 milliseconds.
Wow, that's a 2.7x speed increase. All they did was tell it to write better code.
Yeah, and that's the power of what he calls this iterative prompting. It's almost like we're having a conversation with the LLM and guiding it toward a better solution step by step. And in the next iteration, things get even more impressive.
What happened in round 2? What did Claude do?
It really went above and beyond. It tried to incorporate things like multi-threading, vectorized operations, essentially trying to parallelize the computation. These are all techniques that, human programmers use all the time to get significant speed boosts.
Wow, so it's almost like it's learning from our prompts and evolving its approach.
Precisely.
Pretty amazing.
And the result was a 5.1x speed increase compared to that original code. However, with that increased complexity, also came a few bugs that Wolf had to fix manually.
Okay, so there's a trade-off here.
Yeah.
LLMs can come up with some incredibly clever solutions, but they might not always be perfect right out of the box.
Absolutely. Yeah, that's a great observation. And this pattern actually continues for the next few iterations. Things get, shall we say, a bit more complex. And Wolf realizes that he might need to take a little bit more control over this optimization process.
Okay, so it sounds like things are about to get even more interesting.
You'll find it fascinating that as Wolf continues to prompt for better code, Claude starts adding features that he never even asked for.
Like what kind of features are we talking about?
Oh, things like metrics logging and signal handling, almost like it's trying to build an enterprise-grade application.
So it's almost as if Claude is interpreting better code as More robust, more feature-rich,
Yeah.
not just necessarily faster.
Precisely, yeah. And buried within all this added complexity was a surprising discovery. Claude managed to achieve a 100x speed increase by leveraging a library called numba and async operations.
Wait, 100 times faster? That's remarkable. I wouldn't have thought just saying write better code could lead to those kinds of improvements.
It really highlights the potential of LLMs to, find these creative solutions that may not be immediately obvious to a human programmer.
But it also sounds like there's a danger of things getting out of hand a little bit, with the code becoming bloated and overly complex.
Yeah, that's a valid concern, and that's where prompt engineering comes in.
Okay.
Wolf realized that he needed to be more specific with his instructions to, guide Claude towards the type of optimization he was looking for.
So he decided to lay down the law a little bit.
Exactly. He created a system prompt that essentially told Claude, your goal is to maximize efficiency, use parallelization, adhere to style conventions, and absolutely no unnecessary code.
So it's like he's giving Claude a performance review
Yeah.
and setting some clear expectations.
Exactly, and the results were impressive. With this more focused prompt, Claude delivered a much more concise implementation using numpy and numba right from the start and focusing on integer operations for that digit sum calculation.
Okay, so by being more specific with the prompt, Wolf was able to kind of steer Claude toward a more efficient and elegant solution.
Precisely, and this time the code achieved a 59x speed increase compared to the original, all while being much cleaner and easier to understand.
That's a fantastic outcome. It really shows the power of prompt engineering to shape the output of LLMs.
Yeah.
But did Wolf stop there?
Of course not. He was curious to see how far he could push this optimization.
Of course.
So he continued to iterate, but instead of simply asking for better code, he got a bit more creative with his prompts.
How so?
For example, he told Claude, your code is not fully optimized, and you have been fined $100. Make it more optimized.
So he's really trying to tap into Claude's competitive spirit here. Maybe it's fear of financial penalties.
Yeah, it's a fascinating approach, and it definitely got Claude's attention. It tried to incorporate even more advanced techniques like parallel processing using parallel true in the number decorator, and it became quite fixated on using bit shifting for that digit sum calculation.
Bit shifting, that sounds pretty technical.
It is, and it's actually a very clever idea in theory.
Okay.
Bit shifting operations can be extremely fast, but it turns out they don't work as expected for decimal numbers.
So it's a good idea in principle, but it didn't quite pan out in practice.
Exactly, and this highlights an important point. Even with prompt engineering, LLMs can still make mistakes, or hallucinate, as Wolf calls it.
Okay.
They might come up with solutions that seem brilliant at first glance, but contain these subtle errors or flaws.
Right. So it's a reminder that we still need to be critical of their output and not blindly trust everything they generate.
Absolutely, and this pattern continued in subsequent iterations.
Really?
Claude tried to implement even more complex techniques like SIMD operations and chunking,
Okay.
but it kept running into errors, often related to that bit-shifting approach.
It's almost as if Claude was getting carried away with its own cleverness, trying to impress us with its advanced knowledge, but stumbling in the process.
That's a great analogy. It's like watching a brilliant but overeager student trying to show off all their knowledge, even if it's not always relevant or accurate.
But even in those missteps, there are some valuable lessons to be learned, right?
Absolutely. For example, Claude's attempts to optimize the code really highlighted the potential of number for performance gains, something that Wolf hadn't fully appreciated before.
So even when it was making mistakes, it was still sparking new ideas and kind of pushing the boundaries of what was possible.
Exactly. And in the final iteration, after much trial and error, Claude finally managed to produce a working, highly optimized solution, achieving a remarkable 95x speed increase.
That's incredible. So it seems like the answer to our initial question is a resounding yes.
Yeah.
You can make LMs write better code by prompting them to do so.
Yes, but it's not a simple one-click solution.
Right.
It's a process. It's a journey of iterative refinement and collaboration between human and machine.
It's about understanding the strengths and weaknesses of LLMs, guiding them with clear instructions, and being prepared to step in and make corrections when necessary.
And perhaps most importantly, it's about recognizing that LLMs are powerful tools for sparking innovation, but they're not a replacement for human ingenuity and expertise.
They can help us explore new possibilities and push the boundaries of what's achievable, but they still need our guidance and our oversight.
What's also interesting is that despite all its attempts at optimization, Claude never considered some fairly basic strategies.
Like what?
For example, it never tried to dedupe the list of numbers, even though with a million random integers, there were bound to be duplicates.
That seems like a pretty obvious optimization to a human programmer.
It does, doesn't it? And it also never explored the possibility of sorting the list, which, while not the most efficient approach, is still something a human programmer might consider.
So even with all its computational power, Claude still exhibits certain blind spots or gaps in its reasoning.
Precisely. It's a reminder that LLMs, as advanced as they are still learning and evolving.
Yeah.
They don't have the same breadth of experience and intuition that human programmers have developed over years of practice.
But that's what makes this collaboration so exciting. By combining the strengths of humans and machines, we can achieve truly remarkable results.
Absolutely. And I think this iterative prompting approach has the potential to revolutionize not just coding, but many other creative and technical fields as well.
Absolutely. It's a powerful technique for exploring new ideas, generating solutions, and pushing the boundaries of what's possible.
And it's something that anyone can experiment with, regardless of their technical background. All you need is a curious mind, a willingness to experiment, and an LLM that's ready to learn and grow.
Big thanks to Curt Robbins for pointing us to this really thought-provoking blog post. It's definitely sparked a lot of interesting ideas and discussion.
If you're interested in learning more about this topic, I encourage you to check out Max Woolf's blog.
Definitely.
He goes into a lot more detail about his experiment, including the code examples and his analysis.
It's a fascinating read for anyone who's interested in the future of AI and its impact on software development and beyond.
And as always, thanks for joining us on the deep dive. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.